Okay, let's turn the tables on this and we'll convert from a logarithmic form into an exponential form. So here's an example. The log of 10,000 base 10 is 4. And if I convert this equation to exponential form, I have the base 10 to the 4th power is 10,000. So there you go. That's what's involved, going from logarithmic form to exponent form. Now, the purpose of learning that is to calculate some logarithms. And some we can calculate that are kind of on the friendly side. So let me give you an example of this. What is the log of 49 base 7 equal to? All right. Well, let me call that x. I'll call that x, and I'm going to change this to the exponential form. So the base is 7. 7 raised to the x power is 49. And I think you can see pretty readily that 7 squared is 49. So x has to be 2. So now we can say that the log of 49 base 7 equals to 2. And we solved that logarithm. Let's try another one. This will be a little tougher. What's the logarithm base 6 of 1 over 216? All right. Now I know instinctively that that's going to be a negative number. And in fact, when the argument of the log function is less than the base, then I think it's true that it's always going to be negative. But anyway, let's see what happens. I'll set that equal to x, and then we'll convert to exponent form. So I have 6 to the x power is 1 over 216. Okay, then what now? Well, 216 is a power of 6. It's 6 to the 3rd power. And to finish this process, I need to make both sides have the same base for their exponent. So I'm going to change this to 6 to the negative 3. So 6 to the x is 6 to the negative 3rd power, because if I bring this number up to the numerator, then I've changed this exponent to a negative. So 6 to the x is 6 to the negative 3, then I think you'll agree that x is negative 3. So I can say then that the log of 1 over 216 base 6 equals to negative 3. All right, well, this is one of the first things you learn about logarithms is how to calculate some easier friendly logarithms. Generally, we can't do this very well. For example, what's the log of 7 base 2? Okay, I don't know. Because if I said that equal to x, then that means 2 to the x has to equal to 7. And 7 is not a power, a nice friendly integer power of 2. So I can tell you what this is approximately because I know how to do it. So actually the log of 7 base 2 is about 2.80735. Okay. And it goes on forever. But if you put 2 and raise it to this power, you're going to get something very close to 7. So we can calculate these things once you learn some more rules of logarithms, which we don't do in this course. But it can be, these things can be calculated. So again, it's a little hard right now to appreciate the use of logarithms, but I'll try to give you some more glimpses of that as we wrap up this section.